The text-to-image Krea 2 model can now be used for image editing, reference-based generation, and face swapping. Let's look at how it works, step by step. Krea 2 is still not a native edit model, but this custom node repository for ComfyUI adds an editing workflow around Krea 2. It lets the model generate a new image while looking at the original image and following an edit instruction during denoising. To use it, clone the repository into your ComfyUI custom nodes folder and restart ComfyUI. After restarting, get the workflow from the GitHub repository and load it inside the ComfyUI. The Identity Edit LoRA is missing. Get the LoRA from Hugging Face and place it inside the LoRA folder. In the workflow, you should find these two important nodes. Krea 2 Edit source patch gives the diffusion model the visual reference. Krea 2 Edit grounded encode helps the text encoder understand the source image together with your edit instruction. Together, these two nodes give Krea model two kinds of guidance. First, visual guidance through source image latent tokens. Second, instruction guidance, where Qwen3VL sees the reference image and the edit prompt given by you together. These nodes create the special input format needed for editing, and the Krea 2 Identity Edit LoRA teaches Krea 2 how to use that format. Without the correct edit LoRA, Krea 2 may not behave like an image editor. Krea 2 Edit source patch patches the Krea 2 diffusion model. During sampling, the model is guided by three things. First, the encoded instruction from Krea 2 Edit grounded encode, where Qwen3VL looks at the reference image and reads your prompt. Second, the source image reference converted into a format the diffusion model can look at. Third, the blank generation canvas from empty SD3 latent image, which gradually becomes the final edited image. So the source image does not affect the blank canvas directly. Something like when we do the image-to-image generation controlled by the denoising value. Instead, Krea 2 generates the new image while looking at the source image as a reference. This reference influence happens through attention inside the model. One thing to watch out for, speeding up attention with options like Sage Attention or Flash Attention can also reduce the image quality. The Krea 2 Edit grounded encode is the understanding node. It sends the source image into the Qwen3VL text encoder along with your prompt. So instead of encoding only a prompt like change the dress color to red, it encodes something closer to look at this image, understand the person, object, and scene, then change the dress color to red. The source patch node helps preserve appearance. The grounded encode node helps the model understand what part of the image your prompt is talking about. Now let's look at the inputs required by these nodes. The Krea 2 Edit source patch. The first input is model. This should be the Krea 2 model after applying the Krea 2 Identity Edit LoRA. Next is source latent. This takes the VAE encoded source image. This connection was also required in older versions of the node, but in the current version we also have separate inputs for VAE and source image. When VAE and source image are connected, the node uses the newer pixel space path internally. So source latent is still required, but it becomes more like the classic or fallback input. Source latent B is optional. It is used for a second reference latent. For a two-reference workflow, the first reference can be the scene connected to source latent. The second reference can be a person, object, or clothing item connected to source latent B. Internally, the first reference gets frame index 1 and the second reference gets frame index 2. This helps the model separate the scene reference from the subject reference. Next is ref boost. Increasing ref boost does not simply increase denoise strength like a normal image-to-image workflow. Instead, ref boost tells the model to pay more attention to the reference tokens. You can think of it as a reference fidelity dial. The value here affects the last reference image. When working with two reference images, it affects the second reference, usually the person, object, or clothing item you want to insert or swap. For a single reference edit, it affects the only reference image present. The value 1.0 makes it neutral. Higher values increase attention toward the reference. Use it when identity, face, clothing, or object likeness is too weak. But if you push it too high, the output can become stiff, copied, distorted, or too attached to the reference. RefBoostA works the same way, but for the first reference. In a two-reference workflow, this usually means the scene image. In a single reference workflow, it usually does not matter much. Next is fit mode. In the current version of the node, fit is the default option, and it is important. Fit is designed to handle mismatched source and output aspect ratios better, especially when VAE and source image are connected. It uses the raw image plus VAE path to prepare the reference before encoding, which helps avoid blurry or stretched references. The second option is crop legacy. This is the older behavior. It center crops the source image to match the target output aspect ratio, then resizes it. Remember, fit only fully works when both VAE and source image are connected. Next is source image. This input takes the original source image. When it is connected together with VAE, it overrides the plain source latent path internally. This is the recommended path in the current version of the node. Source image plus VAE is usually better than only using source latent, because fit mode can resize or crop the image in pixel space before VAE encoding. If the node has to resize latents after VAE encoding, details can become softer or distorted. Source image B is the second raw image reference. Use this with VAE for two reference edits. The order stays the same. The first image is usually the scene, and source image B is usually the person, object, or clothing reference. Ref Boost Mask is optional. It limits Ref Boost to only part of the last reference image. For example, in a face swap workflow, you can mask only the face area, so the extra reference boost focuses there. Without a mask, Ref Boost applies to the whole last reference image. Last is VAE. The VAE is used to encode the raw source image internally. With source image, the VAE enables the newer pixel space path. The node first fits or resizes the image in pixel space, then VAE encodes it. This is usually better than resizing a latent tensor after encoding. The other node, Krea Edit, grounded encode, takes the Qwen3VL text encoder through the clip input. The image input should be the same source image. This lets the Qwen3VL encoder look at the image while reading your edit instruction. Image B is optional. Use it for the second reference image when working with two reference edits. Next is the prompt box. You can keep the prompt simple and direct, like change her outfit to a red raincoat over the black dress. The faced swap worked, and the result is acceptable. Replace the yellow car with the red cartoon car. Keep the main prompt simple. If you want the model to pay extra attention to things like face identity, clothing details, or object shape, use the system prompt. The grounding PX value controls the resolution of the image or images sent into the Qwen3VL vision language encoder. The default value is 768. If an image is larger than 768 on its longest side, the node scales it down while preserving the aspect ratio. It does not crop the image here. For example, if grounding PX is 768 and the input image is 1536 by 1024, it becomes 768 by 512 before going into the vision language encoder. Lower grounding PX values can make the model follow the edit instruction more directly and can use less memory. Higher values can help with identity, faces, and fine visual details, but they may use more memory and can sometimes confuse the composition if pushed too high. A value of 0 means native resolution, so the image is not resized by this node. Last is system prompt. This overrides the default system instruction used by the vision language encoder. It can steer what the encoder pays attention to. For example, a face-focused system prompt might make it focus more on identity details. This is not the same as the edit prompt. The edit prompt says what you want to change. The system prompt changes how the image is described and understood before the edit instruction is encoded. Now let's quickly look at some use cases. In this workflow, I have two images on the left, but initially only the first image is connected to the two nodes we saw just now. My prompt is, the woman is holding a smiling cucumber in her hand. And this is the result. As you can see, the second image is not connected yet, so the model creates a different cucumber on its own. It looks realistic, but it does not match the specific cucumber character I wanted because the model has not seen that reference image. Now I'm connecting the second image to the Krea Edit grounded encode node. This means Qwen3VL can look at the second image while encoding the prompt. The result now understands the idea better, but the cucumber is floating around her hand. One possible reason is that the first image connected through the source patch node still has stronger visual influence. Also, the ref boost values are still neutral for both images. Now I will connect the second image to the Krea Edit source patch node as well. This gives the diffusion model the visual reference of the cucumber. Now the generated result has the same 3D style cucumber face from the reference image, but the black clutch or purse is still present in the woman's hand, so the cucumber appears to float in the air. In this case, I should make the edit instruction clearer. I can update the main prompt to say, the woman is holding the smiling cucumber character from the second image. Remove the black purse from her hand. You can also use the system prompt to guide what the image encoder should pay attention to, but actual edit instructions usually belong in the main prompt. Now the result is much closer to what I wanted. Next, I will try another prompt. Both are standing together for a photo. The image looks fine, but the cucumber is longer than the one in the reference image. In this kind of case, we can increase ref boost. I usually test values between 3 and 4. We can also create a mask for the area we want the model to focus on. Here, I am masking the cucumber in the reference image and connecting that mask to ref boost mask. This did not work consistently in my testing. So now I will increase ref boost for the second image and try again. In my workflow, I also noticed a bug. Sometimes the mask effect does not refresh unless I make a tiny change to the mask. I have not seen many people mention this, so you should test whether it happens in your setup too. Now I will also increase ref boost A for the first image. I will keep it close to the second reference boost, around 3.85 to 4.0. After this, the cucumber in the generated image matches the reference much better. This method worked in most of my tests. At this point, you may have two questions. Why increase ref boost for both images? And why am I slightly editing the mask after changing settings? First, ref boost controls the last reference image, which in this case is the cucumber. Increasing it tells the model to pay more attention to the cucumber reference, but sometimes that is not enough. The first image still needs to anchor the scene, body pose, hand position, and overall composition. Increasing ref boost A helps preserve the first image strongly enough so the second reference can fit into it more reliably. The second issue is the mask refresh problem. With a fixed seed, running the same workflow should return the same result. If I remove the mask, the cucumber becomes longer, which is expected. But when I reconnect the same mask, the results generated are not consistent. If I make a very small edit to the masked boost starts working again. This looks like a bug or cache-related issue in this workflow. Making any changes, like increasing ref boost by 0.1, also fails the mask feature. The project was updated recently, so I checked whether this mask problem was fixed. I ran the git pull command to get the latest updates. The update added a new target latent input to the source patch node, improved some fit mode geometry, and added better warning messages. The new target latent input should be connected to the same latent that goes into ksampler and connects to the latent image. It lets the node know the output resolution before sampling starts, so it can prepare the source image earlier. This can make the workflow more efficient on lower VRAM systems. I tested the same workflow again after updating. In my case, the mask issue was not fully fixed. I could still get the correct image, but it felt more hit or miss in my tests. So I went back to the previous version of the node, the version without the target latent input, and tested again. After restarting ComfyUI, I added the source patch node again, reconnected everything, and tested the workflow. It worked after a couple of attempts, but this still needs more testing. So that is it for this video. I will continue looking for a possible fix for the mask refresh problem. If you try this workflow, I suggest testing it on your current node version first and update later for comparison. I hope this video was informative. Thank you for watching and have an excellent day.